This is number 1b on the review for exam 2. We're asked to take the derivative of y equals the ln of x squared times the sine x of times the square root of 2x plus 3 in the numerator over x squared plus 4, quantity x squared plus 4 times ln of x in the denominator. And we should use properties of logarithms in order to rewrite this before we try to take the derivative. So first thing I'll do is just say that I have a quotient here, so I can break up properties of logarithms. I can say that that's the ln of the numerator, which is 2x plus 3 minus the ln of the denominator. And then I can use more properties of logarithms to break up each of these arguments into sums of logarithms. And same over here, we need to remember to distribute that negative when we do it to this side. So we get y equals the ln of x squared plus the ln of the sine of x plus the ln of, and I'm going to change this square root to the exponent of 1/2. So the ln of ooh, it's not 2x. Let's erase that. Delete. And the ln of x squared. Oh, I did it again, didn't I? Funny. So let's try to get that out of there. Okay, so it's well, I didn't even put the 2x on there. So anyways, the ln of 2x plus 3 to the power of 1/2 minus the ln of x squared plus 4 minus, because we're distributing, it's plus inside here, it's the ln of x squared plus 4 plus the ln of x, but since this negative 1 is right here, we multiply through, so it's the ln of x. And there's no property that breaks that up, by the way. But now we can use another property of exponents, says the exponent of the argument can be pulled down as a product of the with the logarithm. So we have y equals 2 ln of x in the first case. Nothing much we can do here. We have ln of the sine of x. Here we can bring that power of 1/2 down in front. And we have 1/2 times the ln of 2x plus 3. And then here we can't really do anything. Plus 4. Oh, writing off the pad. Plus 4 minus ln of the ln of x. And now we're pretty much ready to take the derivative. So we have y prime equals 2 as a constant times 1 over x is the derivative of ln of x. The derivative of the ln of the sine of x is 1 over the argument, which is 1 over the sine of x, times the derivative of the argument, which is the cosine of x, and then we'll say plus 1 over 2, because that's a constant, times 1 over the argument, which is 2x plus 3, times the derivative of the argument, which is 2, and then same here, minus 1 over the argument, 1 over x squared plus 4, times the derivative of the argument, which is 2x, and then minus 1 over the ln of x. Oops. One over ln of x times the derivative of the ln of x, which is 1 over x. And I don't think I'm going to try to get a common denominator here. I think I'm just going to rewrite a few things. So we have 2 over x plus the cosine over the sine is the cotangent of x. The 2 over 2 cancels, so we have plus 1 over 2x plus 3, and then we have minus 2x over x squared plus 4, and then here we just have minus 1 over x ln of x. And we could get a common denominator between those, but I think I'm just going to leave that. There's other ones that we can simplify. I think that this one was hard enough. It's mainly that you know that you can use properties of logarithms in order to take the derivative of this function without taking the derivative directly.